Hello everyone, welcome to this third video on number theory. This video will deal with the principle of inclusion and exclusion. The last concept was permutation and combination. I hope you enjoyed the concepts of permutation and combination and with the calculated tip which was posted that can easily be calculated without much hassle bustle. Now we will deal with the principle of inclusion and exclusion in this video, the statement of the theorem and the application part of it. Statement of the theorem: let A and B be two finite sets which are going to be subsets of an universal set called as U. So you have something like this big universal set U, and you have your A and B to be subsets of it. So suppose this is going to be my A and this is going to be my B. Then the cardinality of A union B, the number of elements that is common to both A and B. So the elements that are going to be common to both A and B will be going to be the element of A and B. This can be expressed as cardinality of A plus cardinality of B minus cardinality of A intersection B. Okay, so this part which is going to be A, this part which is going to be B, and minus the common portion because this will be added twice in the common portion, right? So it is part of A as well as part of B. So we subtract the common portion from it. Notice that the modulus kind of symbol which we have is going to denote the cardinality of a set. Cardinality meaning the number of elements in the sets. So instead of two subsets like A and B, if I am going to have three subsets, so one is going to be my A, the other one is going to be my B, and the third one is going to be my C. So what we will have to do is the cardinality of A union B union C will be A separately, B separately, C separately. So this is going to be one element taken one at a time, minus we will have to subtract the elements taken two at a time. So what are going to be elements taken two at a time? A and B, B and C, C and A. And then the third one will be elements taken three at a time. This is element taken one at a time, element taken two at a time, and element taken three at a time. The only point to notice or to remember in this formula is the alternative plus and minus signs over here. The first term will have positive term, the second set will have negative everywhere, the third set will be positive, and again when you have the fourth set will have negative everywhere. Okay, so the symbol is alternatively positive and negative. So you can batch elements taken one at a time to be positive, elements taken two at a time to be negative. So this negative being extended for each and every symbol, all of them will get a negative sign. So element taken three at a time will be having positive and so on. So keep in mind the formula as alternatively positive and negative signs. We can generalize this for any number of subsets A1, A2 up to AN. So now you can see that formula A1 union A2 union and so on AN is summation meaning addition of the cardinalities taken one at a time. Second symbol is minus, third symbol is plus, fourth is minus, fifth is plus, and so on. So the nth term will be minus 1 power n plus 1. Now you have one at a time, element taken two at a time, element taken three at a time, and so on, element taken n at a time. So these are going to be the generalization of the principle of inclusion and exclusion. Come on, now we will try to apply it to a problem and see. Problem number 1, there are going to be 250 students in an engineering college. Of this, 188 have taken a course in Fortran, 100 have taken a course in C, 35 have taken a course in Java. So this represents the individual people who have taken the courses in the individual subjects. Further, 88 have taken a course in both Fortran and C. So notice the word and over here. So it is the intersection of both Fortran and C together. So you have 88 of them under the category. 23 have taken a course in both C and Java. Again notice the word and. So this represents the intersection of C and Java. 29 have taken a course in Fortran and Java. So over here it is and. If 19 of these students have taken all the three, so A and B and C, how many of them? 19 of them. How many of the 250 students have not taken a course in any of these programming language? So we will first try to see how many of them have taken at least one course. in one of these. Okay, so let our J represents Java, let F represents Fortran, and like C represents the C programming. So at least one of the course, either a Java or a Fortran or a C. So this is the meaning, at least one of the course. So by our formula A union B union C, this is elements taken one at a time. So F plus C, elements taken one at a time. Second term is going to be negative. Elements taken two at a time. So J intersection F plus F intersection C plus C intersection J. So this is elements taken two at a time. Third term will be positive. Elements taken 3 at a time. So this will be my formula if I am going to replace A, B and C by J, F and C. So from the given data, let me collect what are these equal to. 188 I have taken a course in Fortran. Okay, so F equal to 188. So this F is 188 over here. And 100 I have taken a course in C. So C is for 100. So the C is going to be 100. 35 have taken a course in Java. So Java we have 35. So this I can fix to be 35. 35, 188, 100. The next case 88 have taken a course in Fortran and C. So Fortran and C, Fortran and C. So this is going to be 88. So F intersection C, this I am replacing it with 88. 23 have taken a course in C and Java. C and Java is going to be 23. So whereas C and Java, this is going to be 23. 29 have taken in both Fortran and Java is going to be 29. So this Java and Fortran, let me replace it with 29. And 19 of these have been taken by all the three courses. Students have taken all the three. So F and Java and Fortran is going to be how many? 19 of them. So this last value is now replaced with 19. So I have the course to be taken by at least one course of the number of students. Okay, so number of students who have taken at least one course will be F union J union C. So as such, it is going to be our 188 plus 100 plus the 35 which we had over here, 100 plus 38 plus 188 minus sign of the second two taken two at a time, 88 plus 29 plus 23 taken 80, 29, 88, 23, 88, 29, 23, and third one is plus, you have the last one to be equal to 19. Use your calculators, simplify them, you have the answer to be equal to 202. So at least one of the courses have been taken by 202 students. The question over here is, out of the 250, so this 250 now represents your universal set. So from the universal set, I have three subdivision. One is going to be Java, one is Fortran, and the other one is C. So 250 is going to be your overall strength over here. And out of the overall strength, at least one of them have 202 over here. So this 3 together contributes to 202. So how many of them have not taken any one of these? So they live in this empty part over here. So the number of people, number of students who have not taken any of these three courses. So what will that be? From the universal set 250, you subtract the three components together, 202. So you have this to be equal to 48. So this empty space over here is going to contain 48 students who are not belonging to Java, not belonging to Fortran, or neither they belong to C. So this is how the principle of inclusion and exclusion can be used to identify the number of persons who are pursuing or not pursuing any of the courses. Let us move to the second example. Find the number of integers between 1 to 150, both inclusive, meaning you are taking into account 1 also, you are taking into account 250 also, both inclusive, that are not divisible by any of the integers 2, 3, 5 and 7. So they must not be divisible by 2, they must not be divisible by 3, not by divisible by 5, neither they must not be divisible by 7. So how many numbers are there between 1 to 150 including these two numbers? Okay, so now let us represent the element A to be the number of integers that lie between number of integers that lie between 1 and 250, and that is going to be divisible by the first element over here 2. Okay, so let me represent A for the divisibility of number of elements that is divisible by 2. Let B represent the number of element that is going to be divisible by 3, and C represent the number of integers that is going to be divisible by 5, and let D represents the number of integers that is going to be divisible by the number called as 7. In which case I will use the principle of inclusion and exclusion to find the number of integers that are going to be divisible first by any one of these numbers. So it will be either A or B or C or D by number of integers that are going to be divisible. Then from the universal set, what is going to be the universal set for me? Universal set is going to be 250 in number. From this 250, I will subtract the number of numbers that are not divisible by that are divisible by any one of these. That will give me the numbers that are not divisible by any one of these. So now including the values for A, B and C, D using the principle of exclusion and inclusion, I have 4 subsets over here which are finite in nature. So the formula will be elements taken one at a time. So B plus C plus D. So this is elements taken one at a time. Next I will go for elements taken 2 at a time. So that will include A, B, B and next. So I will have to include B intersection C, C intersection D, D intersection A, and furthermore I can go with B intersection D. Furthermore I will go with C intersection A. 1 2 3 4 5 6 4 5 6. So I have all the combinations over here now. So now elements taken 2 at a time is over. The third one will be element taken 3 at a time. A intersection B intersection C, B intersection C intersection D, B C intersection D intersection A. Okay, and the fourth one will be A, B and D. So this is going to be elements taken 3 at a time. Now the last one will be with a minus sign, element taken 4 at a time. What will be the element taken 4 at a time? A intersection B intersection C intersection D. So this is how the formula of inclusion exclusion will be extended for 4 subsets A, B, C and D. Okay, so now we are the formula ready, and now what is the requirement is going to be the numbers for all this, that is the cardinality of it. So to go for the cardinality, how to find the number of integers that is divisible by any of it, we have something called as the floor operator. So this operator, what does it do is it returns the least positive integer that is divisible by any given number. Say suppose you have 10 divided by 3. You will have the number to go like 3.33333 and so on. So when you divide 10 divided by 3, so this answer is going to be 3.33333. But when we take this floor symbol for this 10 divided by 3, it will be the floor symbol of this non-ending in value. So what it is written is going to be least positive integer. What is the least positive integer over here? 3. So it is going exactly 3 times and then it leaves a remainder. So this will be the integer which we require for our computation. Number of times the element is exactly divisible. So how many times it is going to be divisible? So the divisibility can be obtained by your floor symbol. Okay, so don't make it as a bracket. That is a caution. It is not a bracket. It is just one inverted L to both sides of it. Okay, so in the examination, be careful not to use a straight line, neither to use a bracket, but it is going to be floor. So you just go with the division sign, and whenever you have a non-terminating number, just collect the first part of it in your decimal alone, the whole number alone. That will be the value of your floor symbol, because a floor symbol normally cannot be obtained using the calculator as such. So we will try to take the integer values using our calculators. So we will begin with the cardinality of A. So from the 250 numbers, how many of them are divisible by 2? So divisibility by 2, it is exactly divisible. So I need not have to bother about it. So this is going to be 125 in nature. Cardinality of B, 250, it is going to be divisible by 3. So how many of them are going to be divisible by 3? So I know that 250, when I divide by 3, I have it to be equal to 83. You have it to be 33333. Okay, so when I go for the floor of it, so you need only the integer part of it, so you pick your 83 alone. Now cardinality of C, 250 divided by 5. How many of the integers are going to divide by 5 exactly between 1 to 250? This is exactly divisible, so you will have to not bother about anything. You have the answer to be 50. And D is 250 by 7, number of elements that are divisible by 7. So this will be 250 divided by 7. So you have it to be equal to 35.714. Take the floor of the number. So what is the integer part? The integer part is going to be 35. So I have the elements taken one at a time over here, A, B, C, D to be got over here. So that is done. Now I go on to elements taken 2 at a time. That is A intersection B. What do you mean by it? From 1 to 250, elements that are divisible by 2 is for A, elements that are divisible by 3 is for B. So elements that are divisible by both A and B. So what is going to be both A and B? Go for the LCM common multiple of both A and B. It is 2 into 3, which is going to be 6. So what do we do is 250 divided by 6. So you will be getting the value to be equal to the number of integers, which is going to be exactly divisible by 6. So you have the number to be equal to 41.667. So take the floor of it, so that will leave you with 41. Next element taken with A and C. This is for A is for 2 and divisibility by C is going to be for 5. 5 into 2, that makes it as 10. So this 250 divided by 10, you go. The number of numbers exactly divisible is going to be 25. In the next stage, we go with A and D. So what is going to be A and D? So this is going to be number of numbers between A and D, divisibility by 2, divisibility by 7, 7 into 2, so that makes it as 14. So you go for the number of numbers divisible by 14, take the floor of it, you will find the answer to be equal to 17. Next we move on to B intersection C. B is for the number 3 and C is for the number 5. So 5 into 3, it makes it as 15. So 250 divided by 15, take the floor of it. The answer you will be having is 16. Next you go for B intersection D. So this is going to be 3, this is going to be 7. 7 into 3, it is going to be 21. So 250 divided by 21, you make it, and the answer will be 11. Next we have C intersection D. C is for 3 and D is for 7. sorry, C is for 5 and D is for 7. So 7 into 5, that makes it as 35. 250 divided by 35, take the floor of it, so you have it to be equal to 7. Now elements taken 2 at a time, that is for our second part. Over here 1 2 3 4 5 6, all the 6 elements over here 1 2 3 4 5 6 have been evaluated for. Now the next task is element taken 3 at a time, A intersection B intersection C. So divisible by 2, divisible by 3 and divisible by 5. So it has to be divisible by 2 into 3 into 5. 2 3s are 6 and 6 into 5, so that must be divisible by 30. So number of elements between 1 to 250, that is divisible by 30. Now you go for the 30 and you will have the answer to be equal to 8. The next one is going to be A intersection B intersection D. So it is 2, 3, 7. So it is going to be 250 divided by 2 3s are 6, 6 7s are 42. So go for the number of numbers divisible by 42, your answer will be 5. The next one will be A intersection C intersection D. So this is for 2, you have it for 5, and this is for 7. 5 2s are 10, 10 into 7 makes it as 70. So 250 divided by 70, the number of integers divisible will be 3. And the last one for us will be B intersection C intersection D. So B is going to be 3, 5 and 7. So it is 250 divided by 5 3s are 15, 15 into 7, that makes it as 105. So number of elements between 250 to 105, it goes 2 times. So we are done with elements taken 3 at a time. And what is going to be the last one in a formula? It is going to be elements taken 4 at a time. So what will be elements taken 4 at a time? Intersection of A, B, C and D. So it has to be divisible by 2, by 3, by 5 and 7. 2 3s are 6, 7 5s are 35, 35 into 6, so that makes it to be equal to 210. So 250 divided by 210. So number of numbers divisible by 210 will be, it will go exactly one time only, and then it will leave you a reminder. So we have collected all the elements. The last part is to fix in our formula. What is our formula? A intersection B, A union B unions, A union B union C union D. It is elements taken one at a time, A plus B plus C plus D. Second, you take A intersection B plus B intersection C plus C intersection D plus D intersection A plus A intersection C plus your B intersection D. So 1 2 3 4 5 6, all the 6 elements have been captured. Third one is plus, go for your elements taken 3 at a time, A intersection B intersection C, B intersection C intersection D and C intersection D intersection A and B intersection C B intersection D intersection A, B intersection D intersection A. So this is elements taken 4 at a time, 3 at a time, minus the last one is element taken 4 at a time, A intersection B intersection C intersection D. Substitute in the corresponding positions these values. A is 125, B is going to be 83, C is going to be 50, D is going to be 35. A intersection B is 41, B in A intersection C is going to be 25. The next value is A intersection D, which is going to be 17. Next we have B intersection C, which is going to be 16, C intersection D, which is 7, and B intersection D, which is 11. So substitute it over here, 3 at a time. A, B, C is going to be 8, B, C, D is going to be 2, C, D, A is going to be 3, and B, D and A is going to be 5. So last one, it was 1. So when we do all the estimation, add the data, subtract it alternatively positive and negative, the final answer which we will have will be 293 minus 117 plus 18 minus 1 for each of these brackets, leaving us with 193. So number of numbers divisible by either one of the numbers 2, 3, 5, 7. It is divisible by either one of 2, 3, 5, 7 is going to be 193. So the number of numbers or integers in particularly which is not divisible by any of these integers, namely 2, 3, 5, 7, will be equal to, total value is 250 minus, you go with this 193. So this makes it as 57. So the number of numbers which is not divisible by any of these number 2, 3, 5, 7 between 1 and 250 both inclusive will be 57. I hope this problem has brought an insight on how to go about applying your flow theorem to evaluate the numbers for their exact number of integers for which you can calculate your divisibility. So in this way we can apply the principle of inclusion and exclusion to estimate the number of datas or the cardinality of the number of datas which is going to be inclusive therefore or exclusive therefore. I hope this video has given you an insight into all these datas over here. Happy learning, keep learning. Thank you.